sorry, I'm using a whiteboard today. Okay, hi. Okay, I'm writing hi on the nampak eh? Okay. All right. So today we're going to go into another chapter, which is on hypothesis testing. All right. So for hypothesis, those tests of hypothesis, this will be in chapter 4. Oh, by the way, good morning, assalamualaikum, and good morning to all. Okay. What we did in the third chapter is to estimate the population parameter. Okay. That means you you want to calculate what is the value of your of the possible values of your population parameters. This you use either a point estimate or a confidence interval. Okay, so this is called parameter estimation. So in the first part here, in chapter 3, we use the information from the sample to calculate what is the estimated values of the population parameters. Okay, so that's the first part of inferential statistics. Now in chapter 4, we're going to test the population parameters. So therefore, we would have a guess of what that population parameter is. Okay, and we want to test it. For example, if you go to let's say somebody got caught by the police, and he will be judged by sending him to court. Okay, so in this case, we are going to test or judge on the evidence that we have against him. Okay, and then we deliberate, and then we will have some sort of conclusion on whether he is innocent or he is guilty. Okay, so just note that for inferential, we want to calculate the population parameters. In hypothesis testing, we want to test the population parameters. So there are two different concepts here. One is to estimate, that means to calculate, and the other one is to test. So we would need to have some evidence to check whether the population parameters that we're saying have some values would be true or not true. Okay, so we'll be looking at different measurements, just like we did for confidence interval. We will do testing of of the parameters for the mean, the variance, and the proportion. And again, the highlight is on the population parameters, but we'll be using the sample as evidence to test whether uh, the population parameters have has uh, certain values or not. Okay, so basically here we already have a hypothesized value. Say for example, mu equals to 5, and we will use the information from the sample in order to reject the hypothesis of mu equals to 5. So that is what we mean by testing the parameters of or test of hypothesis. Okay, right. So for example, let's say you have a manufacturer claim that battery life of model Z1 is 90 hours. The life in hours of a battery is known to be approximately normally distributed with standard deviation 8.5 hours. A random sample of 18 batteries has a mean life of 95.5 hours. Is there evidence to support the manufacturer's claim? Test at alpha 0.01. Okay. let me just copy this out on your on the whiteboard. Yeah, hang on for a while. Okay. So if you look at this passage, you can extract some information there. Let's say, for example, um, wait. Okay. Okay. From this passage, you can extract some information. So, for example, you can see it here. Sekejap, wait. Okay. So, from this passage, you can note that there are a few information that we have here. For example, a manufacturer claimed that battery life of model is 90 hours. Okay, here battery life of model Z1 is 90 hours. Can you tell me how to write this equation, how to write this sentence in terms of an equation? Battery life of model Z1 is 90 hours. Can you tell me how to write this statement in an equation? So what parameter that you would like to use it? So mu equals to 90. So here we've got mu equals to 90. Just right here. So this is mu equals to 90. Okay, right, right. So the life in hours of a battery is known to be approximately distributed with standard deviation 8.5 hours. Okay, okay. So here we can extract information here. Standard deviation. So how do I write standard deviation of 8.5 hours here? What does this mean? Anyone? Standard deviation of 8.5 hours. Sigma equals, okay, good. So sigma equals to 8.5, okay? You have got sigma equals to 8.5, okay? So what's the information? So the same thing that I normally do, I would do a population, I would do a sample. So you've got n equals to 18 here. And then what about mean life 95.5 hours? What's that? Mean life 8.5 hours. 95.5 hours mean life. So X bar. Okay, so therefore here I'll put X bar here, 95.5. Okay, so these are all the information that we have. So um, so basic, so is there evidence to support the manufacturer's claim? So that's the question. Is there evidence to support the manufacturer's claim? So what is the manufacturer's claim here? The manufacturer's claim is this. So the manufacturer's claim is mu equals to 90. So here we want to test whether is it true that mu equals to 90. So this is the claim, manufacturer's claim. Okay. Now, so how are we going to test how to find the evidence is through a test. A test of alpha zero. So you want to use a test. Okay, test. So this is called a statistical test. Okay, which is otherwise known as a hypothesis test. Okay, so our hypothesis, what is our hypothesis in this question? What is our hypothesis in this question? Yeah, class. What's the hypothesis? So, do you know what what a hypothesis mean? Do you know what a hypothesis mean? Dalam bahasa Melayu, hypothesis itu maksudnya apa? Kajian awal ataupun it's not kajian awal tu actually is jangkaan awal sebenarnya. It's not a kajian awal. It's supposed to a jangkaan. It's like we thought it is ataupun it's an assumption awal. Okay, that should be a hypothesis. So we do not know whether it's true or not true, right? So now the jangkaan awal or sorry, the jangkaan awal or the hypothesis is that which is the claim. So the manufacturer said, okay, my battery life is 90 hours. So that's a hypothesis. So here we'd like to check whether this hypothesis is true or not true. So that is the nature of a hypothesis test. Now, alpha 0.01 is the measure of the test. So alpha 0.01, I will talk about this later, but this is essentially the probability of making an error. Which I will explain later what this means. Okay, so this means that whatever uh, after you tested it and then you have a decision, so you if alpha 0.01, so there's a 1% chance that you're making an error on your decision. Okay, so because um, we are just human. We are not going to say an absolute conclusion whether the battery life is true or not true. There's always a chance of having that error. So we want to test at an error of 1%. So that means like if I do 100 tests, the 1%, one chance that there's only one probability that I will make an error on this test. Okay, so this is the whole idea of hypothesis testing. Okay, which is you want to test this parameter, this parameter value. So this parameter value depends on the question, can change because parameter can take mu, sigma, bagi pi. Okay, so and you would like to test whether this parameter have a certain characteristics. In this case, it is equals to 90. Okay, right. So in statistical hypothesis test, we have a procedure on how to do this test. Okay, the procedure is I've put the procedure on your e-learning, so you should be able to have that to get that procedure. I've outlined the procedure one by one. So basically, you need to follow the procedure. Okay, a statistical test is a list of procedure that you use to test your parameter. Okay, right. I'm going to go back to my slide. My slide. Mana slide here? So how to test the parameter is using a statistical hypothesis test of procedures. So these are the procedures. So number one, you need to define your hypothesis. You need to define your hypothesis. So this is your hypothesis, yeah. Dalam tak tulis pula. Okay, this. So the first step is defining the hypothesis. What is it that you want to test? Okay, that's the first part. The second part is to use information from the sample as evidence in order to test. Okay, this is called a test statistics. Okay, in this case, we always assume H naught is true. The third step is to decide how are we going to test whether they're guilt apa tu we're going to reject or not reject the hypothesis. So this is like, for example, if you go to a court, if somebody is suspected of doing something wrong, and then they are sent to the court, the judge will measure how the severity his um, of his um, alleged behavior. Okay, so for example, if he is found wanting to rob the house, is there any apa tu does he have any alibi? Um, does the evidence show that he's actually in the house? Okay, so that's the criteria and on whether to reject or not reject hypothesis. And the fourth one is the conclusion. So I will walk you through it on how to do all these steps. Okay. By the way, inside this procedure, I have already outlined what is required at each step. Okay. So we're going to do it um, on the whiteboard again. So let's look at. I'm going to open the whiteboard. Save as image. Okay. I hope you can see my new board. Okay, so here, the first step is H naught. Oh, shit. H naught. We'll use a black one. The first step is to define the hypothesis. So I've got one, sorry, one is to define the hypothesis. So in order to define the hypothesis, so there are two kinds of hypothesis. Okay, so the first one is called the null hypothesis. So this is the null hypothesis. Okay, and this one is an alternative hypothesis. So note that both of them are hypotheses. So here we would like to set on what is it that we want to test. Okay, but in order to do that, we need to define these two hypotheses. Now, what's the difference between null and alternative? So in null and and alternative is the opposite of each other. Okay, but when you want to define, there are three conditions that you have to have. Number one, you need to have, so in order for to have to write this hypothesis, you need to have a parameter. You need to have an equality sign. Equality sign, not equality sign. Sorry. You need to have a not equality sign. What is it that? You need to have some sign. sign lah. You need to have some sign, and you need to have a value. So these are the things that's required is that inside a hypothesis would have these three elements. Okay, and then H naught and H1 would be the opposite. And also, there's another one. H1 is special because H1 have to have an equality sign. So this one have to have an equality sign. So whatever sign that you have, H naught has to have an equality sign. Okay, right. So in our case, our hypothesis just now is mu. So based on the question, this is our question. Just now, our question, so our manufacturer's claim is apa tadi? Mu equals to 90. Okay. So that means I have already have a parameter. I have some sign. I have a value. Okay. So which one do you think I should put this in? Should I write mu equals to 90 in H naught or H1? Faham ke? H naught. Okay, in H naught. Why? Because there's an equality sign here, right? So therefore, I will write my hypothesis in mu equals to 90. Basically, this one, it should be the opposite. What's this? If my H naught is mu equals to 90, what would be my H1? If my H naught is mu equals to 90, how do I write the hypothesis for H1? Okay, but not just not equal. We need to write the parameter. Again, it's going to be you are going to have the parameter. You're going to have the equality sign, which is not equals to, and the value. Okay, it should be the opposite of each other. All right. Okay. Please note that when you write your hypothesis, these three elements have to be in there. You can't just write equals to 90 or not equals to 90. You need to write the full statement of the parameter, because that's the whole that's the whole idea of the story, which is you're testing on the parameters. Okay, okay, that's the first step. Now that's done for the hypothesis, so it's quite easy. Number two, should I write it here? Okay, the second step is test statistics. To write your test statistics. Okay. So when you do this test statistics, you're going to base this on the information that you have from your sample. So in the sample, you got tadi apa? N equals to 18, N equals to apa? 18 18, X bar equals to 95 point something, tak ingat apa. 95.5, 95.5, and then you've got sigma. Sigma equals to 8.5. Okay, all right. So when you do your test statistics, you always assume your H naught is true. And you're going to use your sample statistics, the distribution of your sampling distribution, to calculate your test statistics. So here you need to remember um, this one. You need to remember this one. Nampak ke? You need to remember this diagram. Okay, so remember when we do for confidence interval, mu, the associated distribution, sampling distribution for mu has a z or a t, and then for pi is z, variance, single population variance is chi-squared, and for ratio of variances is F. Can you remember that? Now, that is for confidence interval. So you use these distributions to construct your confidence interval. So so in confidence interval, the in order for you to get your marginal error from Z and T, you get this from the sampling distribution, right? So similar to that, you in hypothesis test you will use the same principle. Okay, you will use the same principle in order to know whether you're going to use a Z uh, test statistics or a T statistics. Okay, so let's look at our question here. Now, from this information from your sample, which distribution are you going to use? Now, do you know your population variance here or standard deviation? So you do know your population variance, right? And standard deviation again. So therefore, which distribution are you going to use now? Anyone? Faham ke? Nampak. Oh, sorry, tak nampak kat bawah. Check kat bawah. Right, it's a Z distribution. It's a Z distribution. It's not T distribution and Nazirul, because even though your sample size is small, remember your mantra, you always check whether mana tadi ni? Oh ni. You always check whether you know population variance or not. If you know population variance, you just use Z. But if you do not know, only then you're going to check your sample size uh, more than 30 or less than 30. And you can choose whether you're going to use Z or T. So, but in this case, you already know your population variance, therefore you're going to use a Z distribution. Okay, so in this code, so for Z distribution, so the probability that you get for is Z distribution is going to be a Z test, okay, X bar minus mu over sigma over Zn. Okay, so note that when you calculated confidence interval last time, you use your critical value from your Z distribution, Z test, times this sigma over Zn to calculate your confidence interval. So recall, so I'm just going to write here recall, but I'm going to rub this off later. So here, so recall in CI, here you use X bar plus minus Z alpha over 2 sigma over Zn. So remember last time I said this, you get this from this, right? Okay. But we're not going to use the confidence interval, but I'm going to say that that is how I recall that is how you got your confidence interval. But now we're going to use the transformation of your sampling distribution to calculate your test statistics. Okay, so in this case, you need just to plug in your values. So here you already know the value of X bar. So the value of X bar here is going to be apa? Oh, is going to be 95.5 minus 90 divided by 8.5 and 18. Okay, so you should be able to get the value of 2.7452, I think. Then this before, let's just check. Tak ada lah pula. Tak ada. 2.7452, I think. Sekejap 2 point berapa? 2.7452. 2.7452. Okay, so 0.7452. So that is the value of your test statistics based on your on the information from your sample. So x bar you get from here, sigma you get from here, n you get from here. Now notice for mu, since you're assuming H naught is true, therefore you're going to use the value here. That's why the equality sign is very important. Because if you don't have the equality sign for your H naught, you cannot use the value of 90. Okay? Right? So that's why H naught is always have to have an equality sign. Okay. Right. So that's the second step. For the third step, it's going to be a decision rule. Decision rule. So for a decision rule, you will use a distribution to check this value. Now, since you have a vec test here, so vec test is just a value, a single value. If mu really is equal to 90, therefore the value of your sampling statistics ataupun vec test or vec score is going to be this value. So we are going to compare this value with the standard value on a standard Z distribution. So this is how we're going to check. So here we're going to compare, since you have a Z test, so you're going to compare with a Z distribution. Okay, 0. And here we're going to, in decision rule, we're going to make a rule on whether you're going to reject or not reject H naught. Okay, so about here we always assume H naught true. We're going to see whether we can contradict this assumption of H naught is true. Okay, so therefore we need to have an area in which we want to reject. So in this case, H1 is not equals to. Okay, so therefore I'm going to use two areas of rejection. Since I'm going to test this one at alpha 0.01. Okay, so here therefore since tak nampak so H naught at alpha equals to 0.01. Remember, alpha is the probability of making an error. So therefore, since I have a two-sided shaded rejection region here, so this is going to be alpha over 2, and this is alpha over 2. Okay, so this is going to be 0.005. Equals to 0.005. Okay. Now, if this is 0. And so this area of shaded area is also called the reject, the area of reject H naught. So if my value 2.7452 lies within the shaded area, so I'm going to reject my H naught. So reject H naught. Okay. So here is the do not reject region of H naught. Reject H naught. Okay. So if this is alpha 0.05, therefore the corresponding value for here is vec 0.005, which is going to be 2 point berapa? 2 point, what is that value? Anybody? 2.5 something, huh? What's the value of vec 0.005 class? 2.5758. 5758. 58. Okay, and this point here is going to be minus 2.5758. Okay, now since this is 2.5758, where is the position of 2.7452? Is it in the rejection region or non-rejection region? 2.7552, is it in the rejection region or non-rejection region? So here the point is we want to compare the value of the one that we get from your observation against that of a standard normal of a standard distribution at alpha 0.01. So dia dekat rejection region or non-rejection region? Rejection region. So here, if you look at this point here, let me just do this. So 2.752. So this point here, 2.7.2 kat sini. Kan? So this is 2.7452. 2.7452. Okay, 2.7452 here. Okay, so the point here is here compared to that. So therefore, we can make a decision now. So since our Z test is greater, in this case is greater than Z 0.05, the Z test is 2.7452 is greater than Z 0.05 at 2.5758. Therefore, we can we reject H naught. We we reject we reject H naught at 1% significance level. Okay. So if we reject H naught at 1% significance level, if we reject H naught here, then we're saying that this might not be true, right? So what does this imply? If we reject H naught 5% level, so what does this imply to the manufacturer claim? Can we support the manufacturer's claim? Cannot. Yes, because the claim in this case, the claim is here, yeah? So this is the claim, right? So, so this H naught in this case, H naught is the claim. This is the claim. This is the manufacturer's claim. Okay, so therefore, there is no evidence. There is okay. In this case, there is evidence to reject it. There is evidence, so there is evidence. Oh shoot, to reject, to not support, to not support the manufacturer's claim. Okay, so so basically these are the steps for hypothesis testing. So here you have the first one is your hypothesis. Okay. Now, whatever that you want to support can be in the form of H naught or H1. It doesn't mean that every time you want to support a claim, the claim has to be in H naught. No, because both of these H naught and H1 can be your claim or whatever that you want to test. Okay. But H naught always have an equality sign, and then H1 is always the opposite of it. And apa lagi? And so, and then the elements in your hypothesis have to have a parameter, have to have some some sign and some value. And the second step is you will use your information from your observations as evidence or as evidence or input on whether to judge your decision of whether you're going to support the hypothesis on or not. So this is dependent on the parameter. So in this case, we want to test the mean, and so you have to check what is your parameter that you want to test and the information from the observation to know what statistics that you're going to use. So let's say I want to test sigma equals to 90, then I cannot use a Z test. What would what should I use then? Okay, so suppose my H naught is sigma equals to 90. Yes, say, and H1 is sigma not equals to 90, not equals to 90. Um, which which as statistics, which distribution should I use for my test statistics? Here I'm dealing with I'm testing for sigma. Sigma, there's only one population. So which distribution should I use for my test statistics? It's not F distribution, George. F distribution is for ratio of variances, right? So it's not T distribution. T is only used for mean, right? So that's why you need to remember this. You need to remember this diagram. This diagram you need to remember. So here, if you want to check for single population variance or standard deviation, chi-squared. Ratio F. T distribution you only use when you do not know your variance and n is small. You use T. All right. So this diagram, please do remember that. Okay. Um. Okay. So the answer is chi-squared. Okay. Squared. Lagi satu. Let's say I want to. Okay, another test. Copy. Um. If I want, suppose I want to test I equals to 0.9 and pi not equals to 0.9, which distribution should I use for my test statistics? I really should, right? Plus, if I have h naught pi 0.9, h1 pi not equal is only z. Yes, that's right. Okay. So all these, so how do I know what is the formula to use? You can look it up on the statistics table. You can directly find it there. Unlike confidence interval, all the formulas for your test statistics is in your statistics table. You can use it directly. Okay. Now, okay. I hope it's clear there. I'm gonna save this as image. Now, now that's a variation for the question. So in the question before, you have mu equals to 90, but there's a possibility that mu will not be equals to 90. Mu will be something else. Okay. So for example, okay, what about this one? I have the same question here, but now I'm going to use exceeds. Battery life of model exceeds 90 hours. Okay. So model exceeds 90 hours. How do I write that in an equation exceeds 90 hours. Battery life exceeds 90 hours. How do I write that in an equation? How do I write my H naught and H1? Okay, how do I write H naught in H1? Can you see what I'm putting up? H naught. Uh, apa benda yang Louis Sentang, what is it that's greater or less than? It is not complete. Remember, you need to have a parameter, you need to have a sign, and you need to have a value. Let's look at the slide again. You need to have, okay. So remember, look into your, so look in the steps here. Your statement about the parameter should have, your statement about parameter should have apa benda? A parameter, have to have a sign, have to have a numerical value. So those three conditions have to have. So how do I write? H naught. Okay, lagi satu kat sini. H naught needs to have an equality sign. H naught needs to have an equality sign. Okay. Louis, you need to betulkan balik you punya equation. Ada one item missing. Tang, H naught greater, you don't have a parameter here. Louis pun, you don't have a parameter. Tang, there's two wrong there. No parameter and it's only greater than. It doesn't have an equality sign. Afiq, you don't have an equality sign. And for H naught, Antonius, you don't have a parameter. Sham, X bar cannot be used for a hypothesis because you need to have a population parameter. Okay. Mana lagi? Tang, mu, apa benda? Tang, which one? Mu, apa benda? H naught ke H1? Louis, H naught or H1? H naught, not. Mu'min Ali, H naught have to have an equality sign. Tang, H1 is less than and equal. Oh, okay, tu faham. Afiq, H naught, mu greater than 90 doesn't have an equality sign. Okay, now baik semula eh. Now, there are three apa tu? Okay, one condition for your hypothesis, it have to have these parameters, sign and value. Number two, H naught have to have an equality sign. Number three, H naught and H1 is the opposite. Okay, so in this case, so if you have manufacturer's claim, is here, let me just write it here. So in here, in this case, I'm gonna, yeah, I'm going to, okay, check. So mana ni, I need to go to, wait, goes to, okay, good. Chung betul? Okay, Chung is correct. So you can see that H in his in your hypothesis, both of your hypothesis H naught and H1 have a parameter mu, good, and both of them have some sign, good, and both of them have values, good, and H naught. So the question is asking whether that the battery exceeds, right? So exceeds. So here your claim is on your H1, right? So H naught has an equality sign. So it's the opposite. So this is correct. Okay? So it satisfies all the condition. So I'm going to show you my the jawapan. Stop presenting window. Alamak. Here. What? So in this case, okay, So you can see that now in this case, my H naught, H1 is my claim. So we start off with mu greater than 90. So you check, so you test yourself, is this H naught or H1? So clearly this is greater than, so it can't be H naught. It has to be H1. So when you've already set your H1, so the opposite of that is less or equal to 90. So please note that conventionally, people or in books, if you look in your lecture notes on your textbook of Zarina et al., they use equals to 90. Equals to 90 is just a conventional way to write. But if you have mu greater than 90, so in principle, it is less or equals to 90. Okay, you don't have to write mu equals 90 if it makes it easier for you to understand. So this is going to be the opposite of this. So greater than is less than equal to. So in this case, it's going to be greater than 90. Okay, for my H1. And the rest, so here the second step is having your test statistics. So we have the same information as example one. So I'm going to have the same value for my test statistics, which is 2.745452. And then for my decision rule, in this case, I'm just going to use a one-sided confidence interval. Why? Because my H1 is greater than. So therefore, I'm going to compare this value to my upper tail value of rejection region. Okay. So here, so here we've got in this question, I'm using alpha 0.05. So here alpha 0.05. Therefore, the corresponding value is Z 0.05, which is 1.645. So when we compare this value with the statistics value, we see that it's in the rejection region. So so we reject H naught at 5% significance level. So here in this question, since I'm rejecting H naught, so in this question, I'm supporting the claim. Okay. All right. Do you have any question? I hope it is clear. All right. So if the question says like the mean, the mean is has at most 90. So what if my claim is battery life? In this Kenneth, you mean in the second example, is it? So in the second example, we're rejecting H naught. So reject H naught. So cover this up. So therefore, we can support the claim because there is no evidence to say that mu is less or equals to 90. So when we reject H naught, we're saying that there is no evidence that mu less or equals 90. So therefore, we can support the claim. But eh? Okay, great. So apa lagi? So you should be able to do task sekejap mana ni? So with that in mind, you should be able to do task the rest of the parameters because there's not much difference there. Alamak, tak ada lah. Syuk. Alamak, tak ada lah pula. Okay, and anyway, you should be able to do tasks the rest of the tasks. So 4.2, 4.3. You can even go to do the hypothesis test for, you can also do hypothesis test questions for variance. for single variance and single proportion. Population, variance, and single population, proportion. Okay. A slight difference for um, ratio of variances and um, difference between two proportions. Okay, but the rest should be the same. So you just follow these rules and you will be okay. Like, okay, any question? Can you go back to where you wrote down when to use which distribution? Ni, kejap kejap. I'm going to put up, I'm going to put up an updated version of the slides with all the things that I've mentioned just now. Wait. Um, is it this one? Is it that one, Shu? Okay. Mm. All right. Any more question? If there ain't more question, yep, let me just um wait. Window my UTM. Okay. Presenting.